corresponding value. That means it will become, say, for theta equal to 60 degree, we can say the value of this r will be equal to 12 by root 3, or we can so to say this is equal to 4 root 3 inch. Right? So this will be the value of r. Now first we need to find out r dot. So r dot and theta dot, these two quantities, these two, r dot and theta dot, these two will be found from the velocity analysis. So you need to do the velocity analysis. So this is where I have drawn the velocity triangle, velocity analysis I am doing. This is your resultant velocity because this is your input motion. So this is your resultant velocity. At any point of time, this spin will, as it is being thrown in this manner, this one will cause the angular rotation of this spin. So it means because of that, this one will have some angular velocity, and as a result of this, the pin will have some tangential velocity. So that tangential velocity is going to be, perpendicular to this OA line. That means it will be along the theta direction. So this is your theta axis, I can say, because theta increases in the the counterclockwise sense. So this is the positive theta and this is positive r. Positive r will be always away from the center, correct? This will be your positive r sense and this will be your positive theta sense. So once I get it, then this is the velocity. Since this is the total velocity of the pin, I can resolve it into two components, one along the perpendicular direction, and we can say this is V, and since this angle is going to be 90 degree minus theta, this angle is going to be 90 degree minus theta, we can say that its component will be, this component will be V cos theta. V cos of 90 degree minus theta means V sin theta. And similarly, this one will be V sin 90 degree minus theta means it is V cos theta. So these two are your velocities. So it is pretty obvious that this is along the negative direction of r. So we can say Vr, which is as per our our equation is r dot, because if you recall what were our equations for velocity, you see this r in r theta coordinate system, our velocity is being given by V bar. So it will be being given by V bar equals Vr u cap r plus it will be V theta u cap theta. So this is our velocity, and if you resolve it in that way, I can say this will be r dot u cap r plus this will be r theta dot u cap theta. So r theta dot u cap theta. So these will be your two velocity components. So I can say from here that our Vr must be equal to r dot and V theta that must be equal to r theta dot. So naturally, since Vr is being given and r dot is being given, so I can say it should be minus V cos theta. Since theta equal to 60 degree, so in that case I can write that r dot value, that means this r dot should be equal to minus 1.5 feet per second. You need to mention the unit properly. Since it is being given feet per second, the velocity unit is in feet per second. So I see that this will be, minus 1.5 feet per second will be this velocity or the value of r dot. The minus sign signifies that with time the value of r will decrease. So it is clearly so because your arm will be rotated in the anti-clockwise sense, and that will see the the decrease of this distance between O and A. So this is basically, if you see, you can consider that there is a reference frame, and that reference frame is being mounted on this slotted arm, and this slotted arm is rotating, which means that there is a relative motion of this pin with a person who is standing in the slotted arm and is in motion with this angular velocity. Let's say this angular velocity here is theta dot. So with this angular velocity, the coordinate system is rotating. the person who is standing in this I mean to say this slotted link is also rotating, but of course he or she will not be able to experience that angular motion, but will record the movement of this pin with respect to the point O, which is absolutely fixed. So this movement is basically called as the relative movement, and we see this is being given me this r dot actually gives me this relative velocity of this point A with respect to the person who is standing on this reference frame. So r dot will be the relative velocity and r theta dot will be observer's velocity, because the observer is standing here, his origin is here, is at a distance of, say, at a distance of r. So this is where the observer is standing, because you are fixing your coordinate system here. So this is your origin. So since you are here, so therefore you know the origin's velocity will be r theta dot. So this will be the observer's velocity. So observer velocity plus the relative velocity will give you the total velocity. So that way also you can look at this equation. You can interpret this equation in this manner as well. Now, since my question is to find out theta dot, so it is simple. We see from here that v theta, that is being calculated as v sine theta, which in this case will be of course 6 by root 3 so much of feet per second will be your v theta. And since v theta is nothing but v theta can be also written as r theta dot, so you can see from here that theta dot, that means the angular velocity, will be 6 by root 3 divided by, this is 12 by root 3 inch. But since this is feet and this is in inch, so you need to convert them. So 12 by root 3 inch means basically it is equal to 1 by root 3 feet. So I can say that this is actually equal to 1 by root 3 feet. So if you remember that, then this should be divided by 1 by root 3. So it means if this root 3 will go up, and you see this theta dot is coming to be as plus 6 radian per second. So this plus sign signifies that your rotation is towards in the counterclockwise direction, because this is the theta plus direction, which corresponds to the counterclockwise rotation or the increase of this arrow. Just note the sense of this arrow here. So this arrow is in the counterclockwise sense. So that shows therefore this way will be positive, and we get theta dot value as to be plus 6 radian per second. So we are able to find out r dot and theta dot. Now for the second case, r double dot and theta double dot, it is pretty simple that we need to calculate the acceleration of the do the acceleration analysis of the system. Now since here the total velocity of this pin is being given to be constant, it is being given with a constant velocity. So since it is being constant, that means your pin will continuously move in this direction with that 12 feet per second velocity. So I can say that since v is constant, we can write that a bar, which is equal to dv bar dt, which is equal to dv bar dt, and that dv bar dt is, you can say that here v bar, how you can express v bar? For that, say you fix up a coordinate system like this, say you fix up a coordinate system this way. Suppose you consider this as the y-axis, and say this direction you consider as to be the x-axis. So in this case, therefore, your v bar will be it will be 12 I cap. So this is basically going to be constant. So since it is constant, the acceleration is going to be null. So that implies that your AR, this is also null, and A theta, that is also being equal to null. So AR and A theta both being equal to null, because 0 bar can be written as AR u cap R and plus A theta u cap theta, because this can be written in this manner. we can write it in this way. This is AR U cap R plus it will be A theta U cap theta. So since this is being given to be equal to null, so it simply means that AR should be 0 and A theta should be equal to 0. So since AR 0, so that gives me the thing, the full expression of AR is R double dot minus R theta dot square, and this result is turning out to be 0. So essentially that means that your R double dot is equal to R into theta dot square, and you know that you have already found out everything. Your R is known to be 1 by root 3 feet, your theta dot is known to be 6 radian per second, so you can ultimately say that it is 36 by root 3, or we can say this is 12 root 3 feet per second square will be the value of R double dot, and it is turning out to be plus. What it means is that although the velocity is in this direction, the R component of velocity is towards origin. So this is your R component of velocity, this is your VR, but your acceleration in the R direction is going to be positive, because this is turning out with a plus answer, so it is going to be positive. So this is going to be your R double dot. That means the relative acceleration is positive, which means that your relative velocity is continuously decreasing as this one will rotate in the counterclockwise sense. So you can make so many conclusions from this problem. So I will ask you that do not only solve the problem, try to analyze it from the various perspectives, because there are so many questions that may be hidden inside a problem. So you need to just think for a while. It will be simpler for you to find out so many observations from this given problem. So this will be your value of R double dot, and once this is known, now we can say come to this equation. This equation gives us A theta equals null. So A theta nulls means we have 2 R dot theta dot, which is the Coriolis component of acceleration, plus it will be R theta double dot. So this value should be equal to 0. And as a result, we can say from here that theta double dot turns out to be as minus 2 R dot divided by R. This is 2 R dot divided by R into theta dot. So you can plug all the values, because all remaining values are known to you. You have already found out in the above steps the required expressions. So just put this inside this equation and you will be getting the theta double dot. And since your R dot is coming to be negative, so ultimately theta double dot is turning out to be positive, because you need to put the R dot value with its sign, just do not put its magnitude. So now since R dot has been found to be negative and you have a negative answer, negative sign here, so these two negatives will ultimately make it plus, which means that as this ramp will be moving towards its left, correct, this theta will increase with theta dot, and theta dot will continuously increase, because the angular velocity and angular acceleration, this will be the sense of angular acceleration, angular velocity and the angular acceleration both are acting in the same sense, which means that your theta dot will be continuously the angular velocity of this link will increase till the physical domain of the motion takes place. That means there is a limit up to which this can continue. Beyond that, the motion cannot be transmitted. So you can think of up to which point this link will move. It does not mean that this one will move for an indefinite period of time. No, because it has certain the kinematic constraint after which this leftward rotation of this link will stop. So someone can ask you the question, after what, how much will be the angle at which this link will come to a total stop. So that will be an additional question not being asked in this question. But these are the additional things you can find from the problem statement and can configure your own questions and try to answer your own queries. So this will be therefore the complete analysis. Now there is another alternative method of doing it. You see here I have done it from the physical, the understanding of my velocity components and everything. But this problem can be also tackled mathematically. How the problem can be tackled mathematically, I just show you, and I will ask you to complete the remaining steps at your home. See this problem. There is a geometric constraint being given to this problem. What is the geometric constraint here? Now, if you look at the structure of this, this is called a mechanism because you have so many interconnected links here and that produces a mechanism. So here there is a geometric constraint. What is the geometric constraint? Now, this analysis shows that come what may be the value, this thing r sine theta, this is going to be always constant. Why it is so? Because you see r sine theta basically represents this height, and since this height is a distance between two fixed center lines, so it is not going to change during at come what may be. So therefore this is the constraint condition. This is called, we call this as the constraint equation. So this r sine theta that is going to be constant can be treated as a constraint relationship. We can say this is a constraint relation, and we can use this constraint relation profitably to analyze our subsequent kinematics. For example, I can start differentiating this equation with respect to time, noting the fact both r and theta are functions of time. So I can differentiate this and can get the thing from here. Say for example, if I differentiate, it will be r dot sine theta, correct? Then we have plus r theta dot cos theta, this will be equal to 0. So since we have this relationship, so we can say from here that the relationship between Vr and V theta, so this is, we can say Vr, and this we can say is V theta. So we can say that Vr by V theta, or rather we write it in the reverse manner. We say that it will be V theta divided by Vr, correct? V theta by Vr, that is going to be equal to minus tan theta. So we say that this is going to be minus tan theta. Now since we have already found that r dot is negative, correct? So ultimately this one is going to be negative quantity. So this negative and this negative will make it plus. So I can say from here that V theta ultimately can be written in this manner, that it will be r dot, this negative value of r dot will make it plus. So I am writing it in a plus manner, just showing you the magnitude, and this becomes r dot tan theta. So if you compare it, for in our case the theta is being given to be equal to 60 degree, so which implies that your tan theta value that should be equal to √3. And you can therefore say from here that your V theta that turns out to be as r dot. So r dot we have found to be equal to how much? 6 by √3, and 6 by √3 into tan theta. So it means that it will be 6 radian per second. We can write like that. So we can, sorry, I think I made a mistake. This will be 6 feet per second, sorry. So it will be how much? R dot is being given to be equal to how much? R dot is, sorry, R dot I bhul likhechi. R dot is 1.5, sorry. So R dot value is 1.5. So we can write in this manner we can say that it will be 1.5. So I can say it is 3 into root 3. I just take this negative sign out from my life. So it is 3 root 3 by 2. And remember, this is being given to be r theta dot. So r theta dot, and the value of r is known to be equal to how much? 1 by root 3 feet. You remember that 1 by root 3 feet. So 1 by root 3 feet r dot, the value of, your r. So 1 by root 3. So that 1 by root 3, it gives us the thing. So from here we can say that the theta dot value will be equal to, this is 3 root 3 by 2 into, this one will be how much? This will be root 3, na? So it will be root 3. I made a mistake somewhere. I think I have made a mistake. Where I have made the mistake? Oh my God. So just see here, I may have made some numerical mistake here, but this thing will be there, and you can analyze the motion. What I try to show you is that you could have analyzed this equation. You could have analyzed this equation by considering this situation, that r sin theta is equal to constant, and from there you could have done this and would have found out your relationship. I think here somewhere I made any mistake, and you can get that value, what should be the case. So the constant relations also can be profitably used. Constant relations can also be profitably used in order to find out this thing. So sometimes you may have to use the constant relation, or sometimes the complete resolution of your velocity expressions will give you, the complete this thing will give you the thing. And you need to remember another thing, that say for example someone can think that here I know the value of r dot and I have used this. So there is another thing you can use, because this is going to be, as say for example, this is going to be constant. At the same time, you see from here that your r cos theta, that is being equal to x. So r cos theta is this distance. You see, this r cos theta means basically you are talking about this distance, correct? This is your r cos theta value. This is your r cos theta. So this r cos theta, correct? So this r cos theta, the rate of change of this r cos theta is actually equal to v. And since your v is directed towards left, so that actually means that your this thing, if you differentiate, you can write from here that it will be r dot cos theta, then it will be minus r theta dot sin theta. That must be equal to your x dot, and this x dot is being given to be equal to minus 12. So you can use these two equations basically, r dot sin theta plus r theta dot cos theta equal to 0, and r dot cos theta minus r theta dot sin theta equal to minus 12. Imagine these are your two unknowns. I just blocked these two unknowns for you. These are your two unknowns. These are your two unknowns. So for a given theta, you can solve these two equations simultaneously and can have the values of r dot and r theta dot. Correct? So you do not say, for example, here I have used the value of r dot in this. When I am considering only the constant relation, I have used the value of r dot, but it may not be that I do not know the value of r dot. So in that case, you have to use basically these two equations simultaneously, solve these two equations simultaneously, and get the values of r dot and r theta dot. Exactly in a similar manner, you can go differentiate this relationship once, this relationship once again with respect to time, set it to be equal to 0, and here also differentiate this relationship with respect to time, and you will be getting this expression also to be equal to 0. So from there you will be able to get your expression. So accordingly you will be getting it. So 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 we will have this this particular thing. So this is bolo
r এর উপরের দিকে
r এর ভ্যালুটা উপরের দিকে গন্ডগোল হচ্ছে
মনে হচ্ছে।
আচ্ছা, হতে পারে, সেটা হতে পারে। 12 6 বাই কোথায় করেছিলাম
এখানে একদম উপরে যেটা 4√3 করেছেন, তারপরে লাইনের মধ্যে 1/√3 করে।
না মানে
না মানে এখানে
এটা তো ইঞ্চে ছিল, আমি ওটাকে কনভার্ট করে ফিটে নিয়ে গেছিলাম। এনিওয়ে, ইউ লুক অ্যাট দিস, লুক অ্যাট দিস। যদি কোনো নিউমারিক্যাল এরার হয়েও থাকে, তাহলে সেই নিউমারিক্যাল এরারটাকে তোমরা একটু ঠিক করে নিও। তবু আমি একবার একটুখানি আনসারটা চেক করে দেখে নিচ্ছি। এটা আমাদের প্রবলেম নাম্বার কত ছিল জানি?
2/142.
2/142. Okay, so 2/142. You see here the value of r dot is being given to be minus 1.5 feet per second square. আমাদের মনে হচ্ছে এখানটায় থিটা ডটের ভ্যালুটাতে গন্ডগোল হয়েছে। This theta dot value, I think we have made a mistake. It is v sin theta. V is being given to be 12. V sin theta মানে হচ্ছে কত? এখানটাতে গন্ডগোল হয়ে গেছে। এটা √3/2 হবে না? সরি। So v is 12, sin theta হচ্ছে √3/2. So √3/2 মানে হচ্ছে এটা 6√3 হবে। সরি। So this should be তার মানে এটা একটু কারেক্ট করে নিও, নাকি আমাকে বোর্ডে ঠিক করে দিতে হবে এটা?
সে ঠিক আছে, করে
না, তবুও this will be 6√3. This will be 6√3. তাহলে এইখানটাতেই গন্ডগোলটা হয়েছে, এবং অ্যাজ এ রেজাল্ট এইখানে সব এই নিউমারিক্যাল ভ্যালুস গুলো সব তোমার পাল্টে গেছে। ঠিক আছে? সো এই নিউমারিক্যাল ভ্যালুগুলোকে তোমাদেরকে একটু ঠিক করে নিতে হবে। সো দিস দিস সে ফর এক্সাম্পল দিস r ডবল ডট, এই এক্সপ্রেশনটা এখানে r থিটা ডট স্কয়ার এই জায়গাটাতেও একটু গন্ডগোল হয়েছে। সো দিস থিটা ডট ইজ বিং গিভেন টু বি ইকুয়াল টু so this is v sin theta. This will be going to be 6√3. তার মানে এটা হয়ে যাবে কত বলো তো? থিটা ডটটা এখানটা এটাকে ঠিক করে দাও, দাঁড়াও। So this I'll check here. So since this is going to be 6√3, so as a result we can see from here this will be 6√3 ডিভাইডেড বাই এত ফিট পার সেকেন্ড, আর এটাই ছিল হচ্ছে আমাদের কত? 6 ইঞ্চ, তাই তো? তার মানে হচ্ছে 12/√3 মানে 1/√3 ফিট। এটা ঠিক আছে তো?
V theta would be 3√3/2.
Which one will be 3√3/2?
V theta. V sin theta, 3 sin theta.
V sin theta, V is being given to be, my god, V is being given to be 3 feet per second. Sorry, আমি এটাকে 12 বলে যাচ্ছি, সরি। Okay, so this should be then correct you are. So it should be 3√3/2. It's all right now, na? 3√3/2.
Yes.
And then yes, I made serious mistakes. So please check numericals গুলো। আমি কিন্তু এই যে বললাম, আমি নিউমারিক্যালে প্রচন্ড গন্ডগোল করে ফেলি। So we see from here, since this is 3√3/2, তাহলে এখান থেকে আমরা লিখতে পারি হচ্ছে কি, এটা হয়ে যাবে 3√3 divided by 2 divided by r, and the value of r is turning out to be as 1/√3, তাই তো? তার মানে this will be multiplied by √3/1. So it will be therefore 9/2 means it will be 4.5 radian per second. Okay, 4.5 radian per second. So accordingly you just change here as well. এই যে এই জায়গাটাতে এটা 36 হবে না। So you should check it and get your answer accordingly. So either you can use this equation in this process, you can solve it, or you can use this constraint relation and differentiate them once for getting the expression for velocity, and then second time for getting the expression for acceleration. So this is how you can solve your problem. Okay, so I think here, yes, here actually that same thing was there, and from here also you get it to be equal to 4.5 radian per second. So the mistake is corrected. So both the ways you can do it. So I think you have understood this problem, or you have any question, feel free to ask me. দেখো যদি কোনো কোয়েরি থাকে feel free to ask me, except the numericals where I made mistake, I have corrected myself. Is it okay?
Yes, sir.
Yes, sir.
Okay. If it is okay, then we can move on to our next problem. So this is our next problem, wherein we are being given, again there are two slotted arms. One slotted arm is fixed at both ends. This is one end and this is another end. In these two ends, this slotted arm is totally fixed, and there is this rotating arm. This rotating arm is able to rotate with respect to point O. So this is the rotating arm OA. It can be rotated, say this way or that way. We can see that this rotation can take place either this direction or it can take place in this direction. So this way it can rotate. Now this slotted arm OA, this is the slotted arm OA, forces this small pin to move in the fixed spiral guide. So this is, it looks like a spiral, and the spiral equation is given in the polar format. So the equation of the spiral is being given to you. This is equal to R equals K into theta. I think this is called equiangular spiral. So this is the polar equation for the spiral path. That means any point on this, this spiral center line, it goes in this manner. And if you consider the position of this point P, you see at a distance of R and at an angle of theta, the relationship between R and theta is being given by this equation, where K is a constant. It is said that the arm OA starts from rest at theta equal to pi by 4. Okay, it means that at theta equal to pi by 4, at arm was at rest. So there was no rotation of the arm, and so we can say that theta dot is equal to 0, right? And has a constant counterclockwise angular acceleration theta double dot the sense of rotation, and the equation is being given to be equal to how much? This is theta dot is to alpha into t plus theta dot at time t equal to 0. Now since theta dot at time t equal to 0, it is 0, so it shows therefore that theta dot, that's going to be equal to alpha into t. Okay, this is going to be alpha into t. What we have to find out is the magnitude of the acceleration of the pin. Now magnitude of the acceleration of the pin P means that we are looking for the total acceleration of this pin. So we can see from here that the magnitude of the total acceleration means that we can say that A bar, that is equal to how much? This is being given to be R double dot minus R theta dot square times U cap R. This is the radial component, plus we have, this is 2 R dot theta dot, plus we get R theta double dot. This is in U cap theta. So therefore it shows from here that the value of AR, that turns to be equal to R double dot minus R theta dot square, and the value of A theta, the value of A theta is rather equation for a theta, not the value. It is 2 r dot theta dot plus r theta double dot. And we have to find out these accelerations when your theta becomes equal to 3 pi by 4. So when your theta is equal to 3 pi by 4, I have to find out these accelerations. Correct? So this is the expression. So therefore, basically what we have to do is that at that theta equal to 3 pi by 4, when theta becomes equal to 3 pi by 4, I need to find out the magnitudes of r, I need to find out the magnitude of theta dot, need to find out theta double dot, etc. Now it is pretty simple that when this theta dot is being given by this, and also we can write theta is equal to, further if you integrate it, theta is equal to half alpha t square plus, when theta is equal to pi by 4, so you have this relationship. So basically your relationship is theta equal to half alpha t square plus pi by 4. That means if you integrate it right from time t equal to 0, so and you can do this integration because your alpha is constant, you can write this expression. So when theta is equal to 3 pi by 4, so if you substitute this case, when theta is equal to 3 pi by 4, you will be getting the value of t from here in terms of alpha. So you can say that t will be equal to how much? So it is 3 pi by 4 minus pi by 4 means it will be pi by 2. So that will be the time when your theta becomes equal to 3 pi by 4. Correct? So it is simple to find out this thing. So your time requirement will be root over pi by alpha. So at that time, basically you need to find out everything. Now since your relationship is r equal to k theta, and this is your theta expression, so ultimately we are able to find out a relationship as how your r is changing with respect to time. So it is basically equal to r into k theta, and in place of theta I can basically substitute this particular expression, that it is equal to half alpha t square plus pi by 4 into this constant. So this is the function that how your r is changing with respect to time. So if you differentiate now this relationship, so you will be getting the expression for r dot. So r dot will be coming out to be as k into, this will be alpha t, right? So this will be the expression for r dot, and same we will be getting the expression for r double dot, which will be getting basically equal to k into alpha. So therefore, since all these things are known to me, now I can go and plug these values. That means I can say what will be my AR. So I can say that the value of AR will be r double dot. So it means it is k into alpha minus r theta dot square. Correct? And r will be how much? Now you need to find out the value of r when theta equal to 3 pi by 4. That means the value of r at t equal to root over pi by alpha. So essentially we can say therefore we can go at that page and can say at theta equal to this 3 pi by 4, we can get the value of r that is equal to k into theta, because you remember that we are given, this is your equation for this spiral. This is your equation for this spiral. So since r is being given to be equal to k theta, so I can find out when theta equal to 3 pi by 4 what will be value of our r. So that is nothing but this will be r equals, we can say therefore that this will be 3k, we can write it in this way, this will be 3 pi k by 4. So that will be the value of r. So accordingly you can go and plug this value here. That means this will be the value of r. So it will be 3 pi k by 4 into now theta dot square. Now theta dot, you can see from here, this is your theta dot, that is alpha t. Theta dot is equal to alpha t, where t is being given by root over pi by alpha. So we can say that basically theta dot at t equal to root over pi by alpha, that means when theta equal to 3 pi by 4, is basically equal to root over pi alpha, right? So that is being, squared up. So this is being squared up, r theta dot square. So we see therefore that this we need to multiply it by how much? This will be pi alpha, correct? So it will be becoming pi alpha. So you see from here, you can take the common, this k alpha from here. So it is 1 minus 3 pi square divided by 4. So that will be the complete expression for your AR, right? Exactly in a similar manner, now you should be able to come and find out what will be the expression for A theta. So A theta is equal to how much? Now you can get it from this expression. So what you see, you need to find out your R dot value. R dot has been already found to be k alpha t. So at t equal to root over pi by alpha, so your R dot value will be basically root over pi by alpha into alpha, means it will be k into root pi alpha. So that will be the value of R dot. So we can write this will be 2 into root over, this will be k, there will be one factor called k, and it will be root over pi alpha. So it becomes pi alpha into theta dot, and that value of theta dot has been also been given to be equal to root pi alpha. So this will be basically squared up, correct? So it is 2k. So we can say this is 2k into root over pi alpha square. So this is 2k like that. And then we have plus r theta double dot. So you can plug the value of r here. This is the value of r, 3 pi k by 4. And the theta double dot has been given to be equal to alpha. So we don't have any problem here. So it will be 3 pi k by 4 into alpha. So once again, you can take k alpha common from these expressions. So you can say from here, if I do not make any mistake, but this is the general outline by which you need to do your problem. So it will be therefore basically, k alpha can be taken out from this and can be written, this is 2 pi square plus it will be 3 pi by 4. So plug the numerical values of AR and A theta here, and you should be able to
2 pi hobe pi square er
কোনটা গো এটা পাই হবে খালি আচ্ছা ওকে থ্যাংক ইউ সো so it means তার মানে এটা যদি পাই হয়, so it means it will be then 11 pi, correct? So it becomes 11 pi by 4 into k alpha. Please check the numericals, but I am showing you the algorithm. So the acceleration total magnitude is nothing but root over ar square plus a theta square, and now you can come and put all these numericals here to get your answer. So this problem is a good, nice problem. This is little bit difficult than the previous one, wherein we are being given this equation of the path and we are for the velocity and the acceleration. So you know that our problems from this r theta coordinate system can be this way, can be like this, and you can have also the various other types of problems in the book. You can consult them, as I have told you, that solve less number of problems initially to just cover up the concept and then later come back for the review. Our basic equations for the r theta coordinate system. Okay, so with this we come to an end to the discussion of the plane curvilinear motion in terms of the various types of coordinate systems. I like to remind you one point of comment that these various coordinates can be interchangeably used to solve your problem. But you can see very easily, if the problem of this type is being given to you, then obviously there is no point of analyzing the motion of this spin by means of the xy coordinate system or the normal tangent coordinate system, because otherwise the problem would be more cumbersome and little bit difficult as well. So in that case, it is a typical problem for the r theta coordinate system, because your equation is given in the polar form like that. So these are some of the thumb rules by which you will be your choice will be basically driven, that which coordinate system is going to be used to analyze your system. Because I told you in the other day that the main idea of using these three types of coordinate systems is a matter of convenience. So you need to actually select the most convenient method by which you will be able to analyze your problem. Now let us introduce today the next article, which is still we are in kinematics. This will be our last module for particle kinematics, and this is what is known as the constraint motion. Constraint motion. Now this is constraint motion. That means sometimes you see our motion of the particle is unconstrained. For example, when you are throwing a ball, correct, it with some velocity, making an angle, etc., etc., you see the ball moves in a parabolic path, right? So the motion of the ball is basically unconstrained in the sense that it takes place freely. But just now we discussed, in fact, two examples today. Both the cases, you see the particles are constrained to move in a definite direction. For example, this point, this problem where the particle is constrained to move in the slot, and also our last r theta coordinate problem, there also we see that the pin is being guided to move in the slotted arm. So all these are examples of constrained motion. That means there are some external constraints which will force your motion to take place. So that is basically called as the constrained motion. So how to analyze this constrained motion? You know that, say for example, we consider this is a case with multiple bodies. So we have here multiple bodies. That means more than one particle. Multiple bodies which will be ultimately modeled as a particle. Multiple bodies will be taken into account by in this constrained motion. For example, let us consider a case like this. It's a very simple example for you. I am just considering this just to start with. Let us say that this is a table, the horizontal and vertical section, and on the corner of the table we have a this pulley being fixed like this. Now to this the end of this pulley we have a string getting connected here this way, and we have a particle, mass particle, which can be shown in this manner. And to the other end of this pulley, you see there hangs another small particle this way. Suppose this is our the particle of mass MA, say this is A. Let us consider this is frictionless for the time being. There is no frictionless, and here we have particle B having the mass MB. Okay, so the whole thing is placed in a gravity field. So this is the whole thing is placed in a gravity field. So once I release this system from the condition of rest as it is, what I will find is that in absence of any friction on this horizontal surface, the moment I release it, you see this one will try to fall with certain velocity. So this particle will move down with a certain velocity, and this particle will start moving towards this. So here we are having two particles, A and B, so multiple bodies, correct? but the motion of these two are dependent. So that's why this constrained motion is sometimes also known as, when we are, especially when we are having multiple bodies, we call this is dependent motion. So we say these two motions are dependent on each other. So we call dependent motion. So the motion of the particle B depends upon the motion of particle A and vice versa. Correct? So we have how to analyze this. Now this is for you is a very simple one. But through this simple example, we like to produce a systematic method by which we can do it. Now we will be doing it by two methods. Today I will show you the first method, and in the next class we will be showing you the second method. Now in the first method, this is termed as the first method is also called as by recognizing the fact that the string that is being attached here on the system is basically, its total length is basically constant, because the string is neither gaining any new length, neither it is losing any length. So therefore we use this concept. That means the crux of this constrained motion is constancy of the string length. We call this as constancy of the string length. So how we are going to use this constancy of the string length? For example, we consider this is a fixed pulley. For example, we take our reference system here. This is our reference system, and I measure the location of this particle from this reference. So let's say this is how I'll be going to measure my reference. See, this is our reference. Let's say this coordinate, we call it as xb. And similarly, we have, again, we imagine all these are particles, so no physical dimension, size and shapes will matter. So we call this as XA, because I find that this length is absolutely, this level is absolutely fixed, as well as this level is absolutely fixed. So from the two fixed locations, I locate these two coordinates XA and XB, and consider the total string length of this is going to be constant. So if I express this mathematically, what I find from here is this XA plus XB plus the small portion of the string which is wrapped around the quarter surface of the pulley, for example. So we take this as 1/4 pi r, where r is the radius of the pulley, and I find that this total length is going to be constant. Now most of the cases, the dimensions of these pulleys are very, very small. So often this part of the string we are going to neglect, correct? So as a result, for us, neglecting that small portion of the string which may be wrapped around the pulley, which is again going to be constant because of the constant radius of the pulley, ultimately we can say that this XA plus XB is going to be equal to constant. So this relationship, that XA plus XB is going to be constant, is called as our constraint relation. So this equation is called the constraint equation. We call this as the constraint equation. Although we have used here two variables, note XA and XB. These two variables have been used, correct? So apparently the number of variables that are being used to define the dynamic configuration of a system is termed as its degree of freedom. But while defining this, we need to remember that the coordinates or the variables that we will be going to use to define this dynamic configuration, they must be independent of each other. That means there should not be any dependence between them. But here we see there is a dependence. So in that case, basically, we define a concept called degree of freedom as the total number of coordinates that we are using. If I call that total number of coordinates as m, which in this case is 2, because xa and xb, we are using 2 coordinates. So m is the total number of coordinates minus n is the total number of constraint relations. Now, for example, in this problem, we are using 2 coordinates, xa and xb. So m value will be 2. And there is only one constraint relationship. So we have the degree of freedom for this system is equal to 1. So we call this as a single degree of freedom system. Now this single degree of freedom system enjoys a very special place in our study of dynamics, and later also you will see that single degree of freedom system is the most common one, although most simple one, and at the same time most common one. Now, since it is a single degree freedom system, it means that if I give one input, I can find out the output. For example, if the motion of the block A is known to me, I can find out the corresponding motion of block B. Exactly in a similar manner, if I know the motion of block B, that means say if someone is giving some velocity to this block B, then we can also find out the motion of the block A. So that is the beauty, that to get the output you require a single input. Now if you take this relationship, constraint relationship, if you differentiate this equation with respect to time once, basically what you will be getting is the velocity relation. So if you differentiate this with respect to time, you will be getting x dot A plus x dot B, that is going to be equal to 0. So it means essentially that the velocity of, speed of block A plus speed of block B, not the velocity, speed of block A and this is going to be equal to 0, because it is not a vector equation, right? We are using it to be a scalar equation because they are used in 2 different directions. So this is, this is VA plus VB, that's become equal to 0. So it shows therefore that the velocity of block B is, say, for example, minus of velocity of block A. So what it means is something like this: if block A falls in the downward direction. Now you see, if you look at that, if this is moving in the downward direction, it means that your XA is continuously increasing with respect to time. So it means that your coordinate direction, you see, this is your sense, and your motion is also taking place in the same sense. It means that you can take, suppose for example, if it is given that at this instant the speed of the block A is being given to be 5 meters per second. So it means, as per our coordinate system that we have defined, it means that for us VA is equal to plus 5 meters per second. Why this plus sign? Because you see that it's downward motion and the coordinate sense, they are enjoying the same sense. So it means that they will be having a plus sign. So essentially then it means that your VB is turning out with a minus answer. So it is minus 5 meters per second. So it means the magnitude of the these velocities, basically they are same, but they are getting connected with a sign over here which will define the sense of the motion of block B. Because if you see here, you see your VB is turning out to be minus, which means that XB is continuously decreasing with respect to time. So it means that if this motion is in the downward sense, then this motion will be towards the right. Correct? Exactly in a similar manner, you can find that if I say give the motion to block B in this direction, motion of block A will be, of course, in the upward direction. So here again in that case your XB will be positive because your this xb is continuously increasing because of the velocity of the block B towards left. xb is continuously increasing, so your vb will be plus, and accordingly va will come out with a negative answer, which means that xa is continuously decreasing, means it will go up. Exactly in a similar manner, if you differentiate this equation once again with respect to time, you will be able to set a relationship between the two accelerations of these particles. So you see, therefore, by using this string constancy, we can apply this equation and can find out the relationship between the two. Now this was a very simple example. We need not actually use this thing. We can just that by visual inspection we could have done this way. But let's take another example which can be also something like this. Say we have a system this way. We have a pulley here, and this pulley is getting connected with another pulley, and this one end of this string is going to be fixed here, and there is a block which is hanging from this pulley, correct? And there is another string which carries this another block B. So you have two blocks here, block A and block B. Okay. Now if I release this system, and suppose for example, if it is being given that at the instant the block A is having the velocity in the upward direction, say this is the velocity for block A, and suppose this is the acceleration of block A, then what will be the corresponding velocity and acceleration for block B? So again, we can employ here the condition of the constancy of the string length. Only thing to note is that here I have two strings, two systems of strings, one used for this pulley and another used for this pulley. So what I can do, I can plan it in this manner. So if I see, and I can plan it in this way. Suppose I consider the center of this pulley. The center, it is being fixed. So I assume this is to be my reference line. This is a fixed reference line. Okay. So I use the following coordinates. For example, to locate B, I use this coordinate, say this is xb. Then to locate the center of this pulley, which I call it to be the floating pulley, this we say that this will be the center of this. I call this as x1. Okay, and then I use this coordinate from here. I call this as xa, defines the center of this block, and of course the distance between these two ends, which is going to be constant. So let's call it to be h. So you see how many coordinates we have defined here. This is constant, forget this one. How many coordinates we have used here? 3. So will it be a 3-degree freedom system? Let us investigate. See, for example, if I consider, say this is the string 1, correct? So if I say string 1, I consider that the string 1, its length is string system number 1, its length is going to be constant. So since its length is constant, let us express the constancy of the length of the string here. So how much will be the total string length for this one? Of course, we will neglect the small portion of the string which is wrapped around the pulley. So it is pretty simple from here to note that my equation here will be what? This will be x1 plus xb, and that is going to be constant. Correct? So this is going to be therefore my first equation. Okay. Now for the second equation, for the second string length, we see here string number 2. If I see, suppose this is string number 2, we get the constancy of the string length once again. So this is the string. How much will be the string length here? So if I express it mathematically, it will be therefore xa. We can say xa minus x1, that will give this side of the string length, this side of the string length, plus this is, from here to here this is h, from here to here this is h, so let's put h, and this length, that means we need to subtract from h the value of x1, so it is x1, and this is going to be constant. Now since h is going to be constant, I can rewrite my second constraint relationship and can say that it is xa minus twice x1 is going to be constant. So therefore, how many coordinates we have used here? You recall how many coordinates we have used? M is equal to 3.
3. Yes.
And how many constraints we have used? So n becomes equal to 2, because for two strings we have two string constraints. So once again I find that this system's degree of freedom will become
1.
So again it appears that we have 3 coordinates required to specify, but we see ultimately the system boils down to a single degree freedom system. So I have to have just only one input, and that input is suffice to find out the output for the motion of the block B. So if essentially now I eliminate the coordinate x1 from these two equations, I will be directly get the constant relationship between xa and xb, but that will not be a new constraint relation, because this new is actually derived from these two independent equations. So the new one will be a dependent equation. So although I am writing a new constraint, actually it is not giving me any new independent constraint. So what I get from here, if I multiply this by 2 and add this, ultimately I find that xa plus twice xb, this is going to be equal to constant. So ultimate working constraint relation that I will be going to use here is this one, xa plus twice xb is constant. So I use this equation to differentiate this with respect to time, and can say therefore that va plus twice vb is going to be equal to 0, and aa plus twice ab is becoming equal to 0. So these two are very easily derived from just by differentiating this relationship. Now what I am being given? I am being given that this VA is mentioned here, the velocity for block A. Now see, the velocity of the block A is shown in the upward sense, although its corresponding physical coordinate is shown in the downward direction. So it means that for us, VA is being given to be equal, say some value is being given. Let's say I call this as 1 meter per second. I call this as 2 meter per second square. So it means that it will be minus 1 meter per second. So that basically means that the velocity of block B, that will be equal to how much? That is going to be minus VA by 2, which will be ultimately half meter per second, and it is turning out to be plus, which means that the block B, if you look at block B, where is block B? This is block B. Where is its sense?
Downwards.
So it means that block B is having, I can write it like that, half meter per second, and I put an arrow, so like this. So this is how I need to report my answer. Correct? So that is how I can find out the relationship between the two velocities of these two blocks. Exactly in a similar manner, you can find out the acceleration. So AA, of course, here is plus because it is shown in the downward sense, which has the same sense for this position. So AA is taken to be as downward and it is plus, and AB will be minus, which means that the acceleration of the block B will be in the upward direction if the block A moves in the downward direction. So you can therefore see that we can use this constancy relationship between the strings in order to set the constraint equation, use that constraint equation to differentiate them with respect to time to get the relationship between the velocity and the acceleration. So in our next class, when we will meet, we will solve, I will not solve many problems from here because you might have solved such type of problems in your class 11, 12. However, your method will be different. Yes, I know, but your method will be different. Please don't use those methods here, right? We have to solve it either by constancy of the string consideration or by the second method, which I will be going to explain in our next class when we will meet in on coming Wednesday. Okay, so then we will be showing you.
একটু সেকেন্ড কোশ্চেনটা একটু স্যার দেখাবেন স্যার।
সেকেন্ড কোশ্চেনটা মানে এটা
না না স্যার, আগে দুটো কোশ্চেন মধ্যে সলভ করেছেন, সেকেন্ড কোশ্চেন ফাইলের মধ্যে দিয়ে আর থিটা মেইনটেইন করছে ওইটা।
আচ্ছা আচ্ছা, দাঁড়াও আসছি, আমি আগে এটাকে শেষ করি। তাহলে এই ব্যাপারটাতে এই অবধি আপ টিল দিস আই থিংক এনি প্রবলেম। সো আই জাস্ট for the first time I just stop recording of the class at this point.